Addition, subtraction, and multiplication of polynomials is a little more basic than division of polynomials. Division has always brought a new kind of problem, namely division by zero. And because of that, it actually changes fundamentally how these expressions work and properties of them and that kind of thing. In fact, whenever you divide polynomials, you no longer get a polynomial in general. You actually end up getting what's called a rational expression. So we get a totally separate thing. However, we can use properties of polynomials, because essentially that's what we're using, is a polynomial over a polynomial, to simplify these rational expressions into easier to work with things. Sometimes they simplify down to polynomials themselves. Whenever we do polynomial division, whenever we do this, we always have to ask, when is the denominator 0? That's always the first step. Then after we do that, we can simplify it. So for this first problem, 2b minus 5 over 10 minus b, the first step is to ask, when is this denominator equal to 0? And that's quite easy to do. You just set it equal to 0 and solve for b. In other words, we have when b equals 10, the denominator equals 0. So the first thing we must do is say 10, I should say the other way. We should say b cannot equal 10. With that step done, now we can simplify. So we look at the top and the bottom. Can we factor the top? No, we cannot. Can we factor the denominator? No, we cannot. Is there a greatest common factor? No, there is not. Therefore, this thing is factored, and we just say b does not equal 10. Let's move on to the next one. 4t minus 6. First step, let's set this equal to 0 and solve for t. I'm going to add 6 to both sides and then divide by 4. And we get, reducing this by 2, gives us 3 over 2. So we know that t cannot equal 3 over 2. Now we can simplify everything. On top, 4t squared minus 9. This is a difference of two squares, namely 2t squared and 3 squared. So on top we have 2t minus 3 times 2t plus 3. That's the formula for difference of two squares. That's how you can factor it immediately. On the bottom, you see that we have a binomial. There's no need to factor it because there's no power of 2 or greater. But we can take out a greatest common factor, namely 2. That leaves us with 2t minus 3. And you see that 2t minus 3 is on both top and bottom, and those can cancel. And this gives us 2t plus 3 on top over 2, and t cannot equal 3 halves. That's the best we can get there. That's completely simplified. Okay, this last problem, we're going to first rewrite this as the standard form, namely highest power to lowest power. When we do that, it's going to be a little bit easier to factor, that kind of thing. Now on bottom here, we have an m squared, the first term, with a negative. I'm actually going to rewrite this by taking out a negative from everything on bottom. We have negative m squared plus 6m plus 72. Oops. If I take out a negative from everything, all the signs switch. So it's going to be a minus 6m and a minus 72. Just redistribute the negative back in, and you'll see we get back to the regular denominator. Now, these are both trinomials and they're quadratics, so we can use the AC method to factor them. On top, we have a times c. A is going to be 1, b is positive 6, and c is negative 216. So a times c is negative 216, and b is positive 6. So what two numbers multiply to give the top, negative 216, and add to give the bottom, positive 6? You can run through the factors of 216. 1 times negative 216 is negative 216. You add those and you get negative 215. You can run through all those factors. What you'll find is eventually you have negative 12 and positive 18. Just checking my work there. Yep, negative 12 times positive 18 is negative 216. And when we add them together, we get positive 6. The nice thing about the AC method is that whenever a is 1, like it is here, we can immediately factor this thing. And it's going to be the variable m and minus 12 multiplied by the variable m again plus 18. You can do the rest of the AC method if you want. What you're going to find is you're going to end up getting this factored form. It's just a nice little trick to doing it faster when you have these common problems where a equals 1. The denominator also has a equal to 1. So if we can figure out the two numbers, then we can immediately factor it. A times c is negative 72. The bottom is negative 6. Here again, you can try and find the factors of 72. What you'll find is we have negative 12 and positive 6. That's what multiply together gives you negative 72. Add together gives you negative 6. And we can again immediately go to the factored form because a equals 1 here. So we get m minus 12 and m plus 6. As you can see, m minus 12s cancel. And that gives us, I'm just going to write it out in front here, negative m plus 18 over m plus 6. Now, one thing I didn't do is I didn't find the denominator when it equals 0. That's because whenever you have a denominator that can factor, you need to factor it first. So we actually would have needed to do all of this stuff on the denominator to get to this point. When we're at this point, before we cancel anything, that's when we can see when does this denominator equal 0. That's when either the m minus 12 equals 0 or m equals 12, or the m plus 6 equals 0, or in other words, m equals negative 6. 12 minus 12 is 0, and 0 times anything is 0. So we need to exclude 12. And then negative 6 plus 6 is 0, and anything times 0 is 0. So we have to exclude negative 6. Therefore, m cannot equal 12 or negative 6. And that's the reduced form of that rational expression. So this is multiplying rational expressions. Just like in fractions, the first thing you should really learn how to do is multiplying fractions before you do addition and subtraction, because multiplying fractions is a lot easier than addition and subtraction of fractions. So here we have multiplying rational expressions first. So when we have this top one, these are all monomials, so we cannot factor anything. They all can't factor at all. So we can immediately go to the multiplication through. But I would recommend you just get used to canceling everything before you do the multiplication, right? I could say x times x squared gives me x cubed, and then 5 times 4 is 20, x times y is y cubed, sorry, y times y squared is y cubed, and so on. But what I want to do first is I'm going to actually start canceling things that I can, namely this x and that x. And then we have a y here, and these two y's cancel with that y on top. This z cancels with that z on top. Now you can see that this 4 can be reduced to 2, and that 10 can be reduced to 5. So on top we have 5x squared, and on bottom we have 5 times 2. I forgot to reduce the 5's here. Let me just cancel that really quick. Now we have x squared over 2, and that's much more simplified. We do, of course, need to say that x, y, and z, all three of them cannot equal 0, because that gives us a 0 in the denominator. That, again, you have to look at in the very beginning here first before you do any kind of simplification. Always make sure you find the zeros of the denominator first before you simplify. You can kind of, factor everything down, but that's not necessarily simplification. But make sure before you start canceling things, you find when the denominator equals 0. Okay, the bottom one, we can do some greatest common factors and factor it. At the top portion here, I can write this as 5y minus 7. The next one is 3y plus 5. Now this bottom one here, right, this is going to be a equals 1. 1 times negative 35 is negative 35. B is negative 2. Two numbers that multiply to give negative 35 and add to give negative 2 is going to be negative 7 and positive 5. Since a is 1 here, we can immediately factor this thing down into a y minus 7. That's because this thing goes right there. And y plus 5. Same reason. The last one, 5y minus 1. Okay, now looking at the denominators, we see that y cannot be three things. Y cannot equal, looking at this first one here, when y equals 7, that equals 0, and that's a problem. So y can't equal 7. Looking at the orange here, y cannot equal negative 5. And the green here, y cannot equal 1. So with those three taken care of, now we can simplify the polynomial. Normally I just cancel everything in the previous step, but just to keep things clear, I'm going to rewrite it all out with the kind of factored forms of everything. So what can we cancel? We can cancel y minus 7, 5s, and the y plus 5. That gives us 3 on top over y minus 1. And along with this thing here, that gives us our reduced multiplication of these rational expressions. Okay, let's look at next one here. So let's simplify everything. Now there's a lot of factoring we can do here, and so that's what we're going to start with. Starting with the top left, we have a times c over b. And let's see, it's going to be 7, negative 7, and 3, which gives us x minus 7, x plus 3. You can always check your work. X times x is x squared. X times 3 is plus 3x. Negative 7 times x is negative 7x. Negative 7x plus 3x is negative 4x. And of course, negative 7 times positive 3 is negative 21. So we get x squared plus minus 4x minus 21. And that's what we have here. Okay, top right. We can rewrite this as x squared plus 8x plus 15. A times c is plus 15. B is positive 8. That gives us 5 and 3. Again, a equals 1, so we can immediately factor it as x plus 5 and x plus 3. The denominator, the bottom left, is a difference of two squares. X is being squared and 7 is being squared, so we can immediately factor that to x minus 7, x plus 7. And then the bottom right, x squared plus 2x minus 35. Here we have negative 35 over positive 2. And now we see positive 7 and negative 5 are what give us the multiplication of negative 35 and the addition of positive 2, giving us x plus 7 and x minus 5. Now we can look at the denominators and ask what gives us 0 in the denominator. From the yellow, we have positive 7. From the orange, both of these are the same, so they're going to result in the same type of thing. Those give negative 7. And then from the green, we have positive 5. So x cannot equal positive 7, negative 7, or positive 5. Now we can cancel cancel common things on top and bottom. I'm just going to do this right here because this is typically how you would do it on your paper. X minus 7 cancel. Then we have, actually looks like that's it. And we're almost there with the x minus 5 and the x plus 5, but not quite. So we can now write the answer as x plus 3, x plus 3, x plus 5, x plus 7, x plus 7, x minus 5. I'm going to write this as x plus 3 squared, x plus 5, over x plus 7 squared, x minus 5, where x does not equal 7, negative 7, or positive 5. And that is simplified. Okay, to add or subtract fractions, we always need to have common denominators. So that's the first step whenever you do rational expressions as well. We need to have common denominators. This top problem here already has common denominators of a minus 1. Now, since a minus 1 is the denominator, we know that a cannot equal positive 1 because 1 minus 1 is 0. Now, when we have common denominators, we can actually just subtract the numerators and leave it over the denominator, just like you would with fractions. It's essentially the exact same. And distribute that negative, combine like terms, take out a GCF, and now you see that we get 2, where a does not equal 1. Now, of course, we have just a number here, so there's really no net need to write a does not equal 1, because a is no longer a variable in the simplified expression. But it's just for complete sake, it's best to keep that around. Now, in the the bottom problem, we almost have the same denominators. We can make them the same by taking this denominator and writing it as negative a plus b, and then factoring out a negative, giving us the negative of a minus b. And that's going to give us the exact same thing as the first fraction with a negative sign. Now this negative sign we can move out in front to interact with this negative sign, giving us a plus 1. I'll write it out first and then I'll show you the interaction. Might be a little bit clearer for you. Minus b minus 1 over negative a minus b. And now you see that this thing can just pop out in front and make that a positive. So we get a plus 1 over a minus b plus b minus 1 over a minus b. The denominators are the same, so we can combine them. And we can also say that A does not equal B. That's how we would get a denominator equal to 0. As long as we make that stipulation, we can continue and simplify the problem. A plus 1 plus B minus 1. Combine like terms, plus 1 minus 1 cancel, and we get A plus B over A minus B, where A does not equal B. And that's the simplified form. All right, let's keep moving on. Now these two problems do not have common denominators. We're going to need to make them to have common denominators by multiplying by something to do that. So for the top problem, P minus 5 and P plus 5, a lot of the times if you're really not sure how to make these have common denominators, just multiply by the other denominator. That's typically what you're going to be doing in these problems anyway. So the other denominator of P minus 5 is P plus 5, and vice versa. We have that. So let's simplify this whole thing. P plus 5 times 1 is P plus 5 over P plus 5 times P minus 5. And don't multiply the denominators out. Leave them factored. We have to factor everything anyway, so there's no point in multiplying the denominators out. 1 times P minus 5, and of course we have P plus 5, P minus 5. And you'll notice that P cannot equal 5 or negative 5. Now, the denominators are the same thing, so let's subtract the numerators. This negative is going to get distributed into both of these terms. So we get P plus 5 minus P plus 5 over P plus 5 times P minus 5. Combining like terms gives us 10 over P plus 5, P minus 5, where P does not equal 5 or negative 5. And there's our simplified rational expression. Now the bottom one has a denominator that needs to be factored first. So let's do that. M squared plus 4m minus 12. That can be written as negative 12 plus 4. That gives us what? Positive 6 and a minus 2. Since a equals 1 here, we can immediately factor it to m plus 6, m minus 2. So let me clear this up a little bit to make it a little bit clear what we're going to be doing here. So we have m plus 6, m minus 2. We can just ignore this previous denominator. And now we're looking at what do we make these denominators the same by multiplying? What factor should I multiply? Well, if we look at the second fraction here, if we were to multiply this by m plus 6 on top and bottom, you see that we have m minus 2 times m plus 6 now. And that's the exact same thing as the other denominator. So that's all we have to do to make these things have common denominators, is multiply the second one by m plus 6. Sometimes you have to just look at what does this thing need that the other things have. That's a good question to ask whenever you're trying to get common denominators. Okay, now we have 2 times m plus 2 over m plus 6, m minus 2, minus 1 times m plus 6 is m plus 6 over m plus 6 times m minus 2. And these do in fact have common denominators. We can also see that the denominator itself says that m cannot equal negative 6, because negative 6 plus 6 is 0, or positive 2. 2 minus 2 is 0. Okay, adding the tops, I'm going to distribute this negative again. And then I'm also going to distribute this 2. It's going to be important for combining like terms. So we get 2m plus 4 minus m minus 6 over m plus 6 m minus 2. Combining like terms, we have m, let's see, minus 2, I think. Yep. M plus 6, m minus 2. And you see the m minus 2's cancel, giving us 1 over m plus 6, where m does not equal 6, or negative 6, or 2. And there is our simplified subtraction of rational expressions. The last topic for this video is complex fractions, or fractions within fractions. There's a couple ways we can solve these problems, but the big idea is get everything to have common denominators and simplify. So the first way I'm going to show you how to do this is where you multiply everything by the least common denominator of everything. It works out nicely when you have kind of the same kinds of denominators like we do in the top fraction there. You see that 2a, right? 2a is just over 1 and 4 is over 1. And so a least common denominator of everything in that fraction would be 8a. So all I'm going to do is I'm going to multiply everything by 8a on top and bottom. So this is going to end up distributing into each one of these terms, giving me 8a times 2a, or 16a squared, and then 8a times 1 over 8a, well, that just cancels and gives me 1. In the denominator, we have 8a times 4 gives me 32a, and 8a times 1 over a. In other words, the a's cancel, and I just get left with 8. Now, the top is a difference of two squares, so I can reduce everything, right? The first thing is 4a squared, and the second thing is 1 squared. So I can factor that to 4a plus 1 times 4a minus 1. On bottom, I can take out an 8, giving me 4a plus 1. Now, we still need to figure out what makes the denominator equal to 0. And these complex fractions, they require a little bit more work because we have multiple denominators, not just a singular denominator. Now you've seen a little bit of how the simplification goes. Right, we can cancel out the 4a plus 1, but before I do that, I'm going to go back, I'm going to clean this up because I want to look at the denominators that we have. Okay, we have an 8a in the denominator, a regular a in the denominator, and we have a 4 plus 1 over a in the denominator. So we actually have 3 denominators we have to consider here. Of course, the two circled ones, those are going to be a equal to 0. Both of them have that stipulation where a equals 0, we have a denominator equal to 0. But the 4 plus 1 over a, that's a little bit different. And what you can do is just solve for a, right? When you set it equal to 0. Subtract 4. 1 over a equals negative 4. I'm going to multiply by a. And we get 1 equals negative 4a. And divide by negative 4. And you see we have a equal to negative 1/4. So we know that a cannot equal 0 or negative 1/4. I should have done this in the beginning, but I skipped that step. Okay, now we can cancel out these guys, and we can say 4a minus 1 over 8, where a does not equal 0 or negative 1/4. And that is simplified for us. Okay, for the bottom fraction, I'm just going to clean this up a little bit so I have some room in case I need it. I'm going to show you the different way of doing this. The first thing I'm going to do is get everything to have common denominators. I should also, I guess I should also look first and say, what denominators give us 0? So we have 3 denominators again. We have x, y, and then this denominator here. For the first two circles, right, when x equals 0 and y equals 0, we have issues. We also have an issue when x equals negative y, because when x equals negative y, we have in the overall denominator negative y plus negative y, which does equal 0. So we have these three stipulations we have to remember at the very end of the problem. Now let's simplify everything out. The only thing that has complex fractions is the numerator, so I'm going to make the numerator have the same denominator. I'm going to do that by multiplying by the first with y over y, and the second with x over x. That gives me y over xy plus x over xy all over x plus y. I can now combine the tops to be x plus y over xy all over x plus y. And I'm going to write this one as over 1. And now you see that we have a division of fractions. And so this is the same thing as multiplying by the reciprocal, and we take the reciprocal of the denominator. We have the numerator multiplying the reciprocal of the denominator, so 1 over x plus y. And now you see that the x plus y's cancel, and we get 1 over xy, where x does not equal 0, y does not equal 0, and x does not equal negative y. And that is the simplified form of that complex fraction. So the first method is quite nice to work with. I think it's simpler, the method I use on the top. For the denominator, or sorry, for the bottom complex fraction, all you would have had done is multiply top and bottom by xy over xy. If you would have done that to this, you would have gotten a similar type of process as the top one did. The problem, however, is when you have more complex fractions. Sometimes it's easier to think of it as a fraction over a fraction and then multiply by the reciprocal. Either way, though, if you do it, if you keep your head in the game and you do the algebra correctly, you will get the same answer.